Alright, so this is a 2015 O-level paper 2 question. Okay, so let's determine what is this question about. So the highest jump to Earth was made by a skydiver from the edge of the space, right? So the diver was in free fall. So what is free fall? Free fall means there is no air resistance. Okay, yeah, because you are in space. There's no atmosphere, no air, right? So there's no air resistance. So they say that the jump started from a height of 39,000 meter above the Earth's surface and parachute opened at a height of 3,000 meter. During the free fall, right, the G field increased from 9.7 to 9.8. So why is it 9.7 to 9.8? Because you're away from the Earth. You are very far away, right? So it's about the G field not so high. Then you go nearer to the Earth, is increased, right? So the mass of the diver was 80 kg. So part A, estimate the loss in GPE during the free fall. This one is simple. So first thing first, right? You determine the MGH when you are stuck. So initial GPE is equal to MGH. So the H in this case is about 39,000 because you started from 39,000 meter. Then G don't put 10 because they explicitly tell us that this is 9.7, so this is 9.7. So of course the M is 80 kg. Then you calculate. Okay, after that you calculate the aftermath. Okay, so aftermath GPE, right, is equal to MGH. So M is 80, G is 9.8. So of course your H is around 3,000 meter. Then after that you just minus off. Alright. Okay, so the interesting question is the part B. So the effects of air resistance are very small at the start of the jump. If air resistance is neglected, state the energy change that occurs during the fall. So there are two parts to this question, right? So first part is this. Okay, so let's do the first part first. State the energy change. So of course the energy change is GPE to kinetic energy. Because you start very high jump, right? I mean high GPE, then after that you fall, right? Fall through, then you gain speed, so the kinetic energy increases. Okay, the next part is explain using the ideas of energy why the speed of the diver does not depend on the mass. Okay, so of course this part, let me just go up here. Okay, so this principal conservation of energy, right, states that does the speed of an object depends on the mass? Actually it doesn't, but provided that there's no air resistance. Okay, so how do I know that? Okay, so imagine we are considering this scenario where I have two things, right, a feather and a coin inside a vacuum. So you start, then after that you drop it, they will reach the ground at the same time. So of course I use the principal conservation of energy to determine. So at the very start you have only GPE, so the KE1 is 0. Then after that of course you go to the point 2, right? So point 2 is actually at this part, at the very bottom of the tube. But of course before you hit the tube, so just before you hit the tube, all the GPE is converted to KE. So at the start, point 1, right, this is GPE. Then after that, before you hit the ground or the rubber stopper is KE. Then after that, right, okay, then you put GPE2 is equal to 0. So of course you can see that if I put MGH equal to half mv squared, the m can cancel away, so become GH equal to half v squared. And then of course you times 2 left and right hand side, v squared, right, equal to 2GH. So you can see that V is equal to square root of 2GH. So the speed at the bottom only depends on two things, which is first of all the G, second of all the height you are dropped at. But of course provided there's no air resistance. Okay, so that's how we answer that last part of the question. Okay, so of course now GP go to K and explain using about energy, right? Why the speed does not depend on the mass. Of course, how do we answer this? Very simple. First thing first, you just say that since there is no air resistance, then after that of course you say using the idea of principal conservation of energy at the start of fall, the diver possess only GPE. Okay, then of course, before he hit the ground, all GPE is converted to KE. Then after that, you can use a bit of formula. So you can say, since MGH at the start is MGH equal to before you hit the ground is all half mv square. Then you manipulate such that you get v equal to square root 2gh. Yeah, so that's how we answer this type of question. So as long you can actually code the formula to help you bring your point across better. Alright, so just remember, without air resistance, right, the speed only depends on two things, which is the g and the h, and of course you just square root the whole thing, then you can get the answer already. Alright.